just imagine you had thousands of boxes which contain millions of records, which had been accumulated over a century. And then suddenly you had to find a few records which no one has seen or touched in like decades. And on top of that, the organization of files is not really ideal, and you have limited time and resources. So how would you approach this problem? Well, at TC Energy, we've actually transformed ourselves into an organization that now runs on a cloud platform. And this has opened the door to a host of technology solutions and tools that can be effectively used to solve these kinds of issues. So a bit about myself, like Dan said, I'm a technology lead at TC Energy, and I have quite a variety of experience there for over a couple of decades. And recently, in the last couple of years, my focus has been on a product innovation team. So this has been great. So being on a cloud platform, it has enabled us to use cutting edge services based on machine learning to quickly and cost effectively find very specific high value records that would be extremely difficult to do manually. So today I'll be sharing with you how we applied machine learning to solve a mandatory, complicated, and potentially very expensive business problem. So I'll go over a quick overview of TC Energy, and that will lead us to the business problem that we were encountered. And then I'll talk a bit about how we use the machine learning based, how we put together a machine learning based solution to solve that. And then I'll go over the outcomes, and I'll give you the learnings that we kind of came from this solution, which I'm very excited to share with you guys. So at TC Energy, we're a leader in developing and operating energy infrastructure. We operate a network of oil and gas pipelines as one of our areas, and it's mostly natural gas throughout North America, in Canada, US, and Mexico. So ensuring we have a safe, stable, and reliable network of pipelines is a big responsibility and a priority for us. TC Energy's natural gas pipeline supplies roughly around 25% of the natural gas consumed daily across North America. So we operate in a highly regulated environment with numerous government agencies providing oversight. So one such oversight from the US Department of Transportation, Pipeline and Hazardous Materials Safety Administration, came about and has mandated that we had to do a reconfirmation of US pipeline records. A significant focus of the US gas team had become to spend on data collection, analysis, and management. So with an aging pipeline system coupled with growing repository of electronic records, it can take locating some of the required records, like make that a challenge. And not being able to find a record, that could result in the company having to perform rework out in the field, which is very pricey and it's disruptive. So to comply with this new regulation, one of the types of value records our engineers needed to be able to locate are called pressure tests. So with a digital repository of over 23 million associated pipeline records, we have millions of pages containing pressure test data, which is in the form of text, diagrams, and charts that our engineers must search through when trying to locate the results of the pressure test. In addition to having to deal with a large amount of records, the engineers are dealing with over a century of records, some dating back to the early 1900s. And although the key pressured test data remains the same over time, it's not surprising that there are many changes to the way the documents and the charts are formatted. In addition, the records contain both typed and handwritten documentation and imagery. As well, the ownership of the pipeline systems, they've also changed hands numerous times. So understanding where in the repository to find an older document can be a challenge. Manually searching and reviewing these electronic records is both time consuming and introduces missed opportunities in locating high value records. So our business partner, he pretty much asked, how can we leverage technology to reduce costs in performing rework associated with not being able to locate these high value records? So what we thought we needed to do, what we wanted to achieve with the business outcome was reduce the search time to find records, increase the odds of finding the records that they needed, and locate all the required records that would prevent us from having to go do rework out in the field and do rerun pressure tests. So to do this, we felt we needed a quick way to sort the records into categories. And because the records were physical and were scanned, the scanned documents are not digitally searchable. So we needed some form of OCR, or intelligent capture. And we wanted to identify the best tool to do that. So working with our cloud provider, we identified 3 key services to tackle this problem: Amazon Recognition, TextRack, and what's now called OpenSearch. When we first started initiative, it was initially called the Elasticsearch service. So Amazon Recognition, it offers a pre-trained and customizable computer vision capabilities to extract information and insights from images and videos. The service has numerous features, and one such feature is called custom labels. So the custom label feature lets you kind of create a data set, define the data set with labels, then you train and test a machine learning model using your data set, and then you can evaluate the performance of your machine learning model by reviewing the test results. So the product team, which was composed of a few MAOP engineering SMEs and developers from IS, they were able to identify the high value record types, so the formats and the different styles we wanted to find, and then gather together a small representative data set of about 100 to 400 examples of each record type. And then we were able to create a machine learning model using recognition. Yeah, so the process was actually pretty straightforward, and it was done in like weeks to do. The model was then used to enable us to divide millions of these records into about 110 categories automatically. And then the other service we used was called Amazon TextRack, which is a machine learning based service that automatically extracts text, handwriting, and data from scanned documents. And it goes beyond the simple OCR to understand and identify and extract data from forms and tables. However, for our purposes, using these features of forms and tables did not really apply or make sense because of our data set. So we basically just had to use the detect text feature. We evaluated also multiple other OCRing options, but the cost and the terms of use and the quality of the text capture of the AWS TextRack was the best fit for us in this particular case. TextRack also supported the capturing of handwriting, and this ability was key for us because we have like I said, we had a lot of records that go back 100 years or so. And of course, those records contain, the older they are, the more handwriting they contain. And then the third service is not like a machine learning based service, but it was the Amazon OpenSearch. And this really made it easy to ingest and search and visualize and analyze the data. And it's like a fully managed service as well. So we were able to take all the results we got from the first 2 services, the computer vision and the intelligent capture, and put them into a Elasticsearch engine. And then with OpenSearch, the business was able to easily use it. So here's a quick, here's a illustration of the data flow. So on the left top, that's the files all started out as physical, and there was a different initiative from ours that was scanning them while we were looking at our stuff and converting them into PDF files and storing them into our corporate content store. And then from there, our solution would ingest the documentation, do some pre-processing on the files, split them into single page records, and then sending them for processing through recognition to categorize them. And just thought to point out, we did have a category for if the record didn't match any of our defined categories. There was like another category like that, uncategorized, which records would fall into. And then from there, that record would then be sent to get OCR'd. And then from there, all the data stored into OpenSearch. And then from there, the Kibana dashboards with some slight amount of configuration, the engineers were then able to search. And yeah, and then from there, the idea would be that they're not actually going to get a exact result from running through the solution. It creates like a searching tool for them, and it narrows down the amount of records they can search through because it's categorized them into. So they can take 23 million records and narrow it down to maybe like they now only need to search through a couple hundred records to find what they're looking for, which is what was really cool about it. Yeah, so here's like the results, the outcome. So the initiative was very successful. The engineers were able to locate records that were required to cancel multiple rework projects that were in the plannings. In addition, the business was able to actually, as a side effect, they actually located other high value records not related to that particular activity that no one had seen in a long time. So that was cool as well. And overall, the implementation was actually relatively pretty quick to do. It was kind of broken down into a few stages, but each one was like a couple months. And yeah, so, and the costs being in AWS serverless on demand costs, it was relatively cheap to do. So I'll now kind of jump into my learnings that we made during our journey. So I'll begin with the Amazon recognition. So the custom features, the custom label feature of Amazon recognition worked really well for us. We were able to focus the training of our model with an emphasis on reducing the false negatives. So because it was more important for us to capture all the true positives, we were able to keep redefining the data set to do this. So even if we increased the amount of false positives in there, we could live with that. It was like more important for us to make sure we captured all of the true positives. So that was our focus. And the tool let us, or the service let us readjust our labeling and everything to do that with that focus. So basically it's like it allowed us, so we wanted to cast our net, our fishing net, and capture all the fish, right? Even if we catch a few other undesirable fish in there. Yeah, so that was pretty good that we could do that. The process to label the data, train, and evaluate allowed us to achieve a very high F1 score. Like we almost got, it was like a 0.996 was our last running model, or the current model we have running, close to 1. So it was extremely high. We were able to use the using the console to build and define the data set. Yeah, this was probably the least desirable part of that service. It's very limiting and slow, and only one person at a time could go in there. But what was really cool about it was the development team was able to manipulate the manifest file and like through some backdoor code, which really reduced our time and effort. And so AWS really made it easy for us to, or it's easy with that solution, the way they work it to do that. And it's pretty straightforward. it only took a few weeks to kind of come up with a solution. So instead of spending like what could have taken like quite a bit of time to put in like thousands of data set pieces, it only took like minutes. So that was a cool backdoor way of doing it. And we used OpenSearch as well as a way for the business to evaluate the recognition model. So instead of them going through and looking at the results of the model training, the business was able to go in and like see it with their eyes and run queries using that dashboard to see like how the results were. And actually, with that feature, it enabled them to easily validate and identify new labels. So we started out with a model with, I think we only had about 40 labels at the beginning, and we ended up with over 100, 109 or 110, like I said. And when we were doing this relabeling and stuff, we also developed a custom process we call like recategorizing. With this, we are able to define with OpenSearch a query to instead of like to extract a small subset of the records and reprocess them through the recognition model. So rather than, because it'll be quite time consuming and expensive if you wanted to run the whole set of data again after you redid your model. So having OpenSearch there as a tool for us to query with and reduce the size of the data set we want to reprocess was it's kind of something I think you have to do if you're talking like some tens of millions of records. Yeah, so now I'll kind of move on to the Amazon text rec service. The handwriting detection was excellent. Had some issues with reading on some of our charts, and really any OCR tool would have had the exact same issue, and that was because there was a lot of background noise on like the pressure test wheel charts on some of them. They have like numbers all over them, and then you're trying to figure out like text written on top of those charts. So we did experiment with it a little bit. AWS gave us some suggestions of trying some stuff where we would take the image and do some rotations and threw it in like say like 20 times and see what the result is. But we didn't have any success with that. We shared that information back with them. So keeping my fingers crossed that maybe in the future that's something that they can enhance. But really that was the only issue with it. We did have to increase, because we're doing some quite large loads, we did have to increase the concurrency settings with the service because it comes with like a certain set limit. So the process they have is pretty straightforward. You just kind of request the increase limit and you provide them with your estimates of what your load is going to be. And then if it's appropriate, they'll increase it for you. Yeah, and then with the Amazon OpenSearch service, I'd say this was actually, for the development team, this was the most difficult part of the solution to get up to speed on and learn. So like, and not so much like the setup of it, like to do it in CloudFormation and just deploy it. That part's pretty straightforward and works really well. It's kind of like the learning curve to be able to like configure it and know how to use it, because no one on our team had ever worked with this service before. But one of the good things is what we did to resolve that is we did get AWS provided us, we have that premium support, so we get like deep dives if we want to get into like learn about a technology. So we were able to do that with them, and on top of that, we have some online training courses available to us in the company. So we took a few of those. So it took a little bit of time. There's also, you have to secure the solution with Cognito. Then this could be a hurdle for a lot of teams. It's a little bit of a complicated process. For us, it wasn't an issue because I have a background fortunately, in Cognito and Federation support. So that made it easy for us in this particular case. But just be aware that that could be learnings for, I think, most people. Yeah, but on the good side, for the business, man, it was like the learning curve was really short, and it was very intuitive, and they had no time like even going in building their own dashboards, reports, and all that stuff. So yeah, the business. So from their point of view, it was like pretty straightforward and simple. Yeah, and what else I want to say about that? Oh yeah, I thought the full text search engine of the Elasticsearch was really impressive. So what we would do is like we would grab all the text from each record and amalgamate that all into one attribute and dump that into the search engine. And then the business was able to like, just use a few key letters or words that would identify a section of pipe or something like that and in dates. And the query ran so quick. It was like, and which is like that's why the last search is like used for like logs and all that stuff, really. So for this case, it actually like it worked just like that. It worked like really well, and the results were great. So I was impressed. Um, yeah, and yeah, so one of the key things that we used is the AWS serverless application model. They have the same thing with Azure too, like their own serverless sort of offerings. But really, this is the glue that brought all the different pieces together. It was really fast to learn the CloudFormation, to deploy everything, made the integration between our corporate content server and Amazon fully managed services really quick and easy to do, enabled us to like quickly set up a process to track the progress and ensure data integrity as well. Yeah, we had no fussing over compute resources, inexpensive to use because it's all like pay on demand nature of the platform. Required minimal operational support once we were in production. Like you never have to do a patch on those, and scaling was straightforward and a breeze to understand and configure. So with respect to scaling, that'll be the last learning I share. Yeah, this was actually really important for us because our solution grew from after the POC, it was like a couple million records. And it grew to like tens of millions of records. So we obviously needed a solution that could easily scale and seamlessly. So with respect to recognition, it was really straightforward. They have what they call inference units. So when you're turn on your machine learning model, you define how many inference units you want to use. So if you're doing a large load, you increase it. If you're doing a small load, you decrease it. So that's how you control the cost of that service too, right? So, but more importantly, to increase the speed of it, when you're doing big loads, you just increase it. With TextRack, we used some queuing strategy and Lambda concurrency settings to really scale that service. And like I mentioned before, we also had to increase the limit of the concurrency allowed on the backend service. And with OpenSearch, it allowed us to scale up and out. So, and without an outage to the cluster. So at first, when we first started, we weren't experts, or I wouldn't say we're experts yet, but we did have very little knowledge. But after our deep dive and our learnings, we realized we didn't really have the cluster configured correctly. We just had like 2 servers. They were doing the master and the data nodes all together in one. Then we realized, okay, we should have like 5 data nodes and 3 master nodes and prod, and we kind of got that. And we were able to implement all that it was like seamlessly, like the business never saw anything. It was all like done just through the code, and it took like you just put it into CloudFormation and it happens. It's like pretty cool. And then as we were doing large bulk loads and our data really grew larger and larger, it was easy for us just to change the instance types so we could get more CPU, more memory, more compute power. As we watched, and you could watch on the monitor and monitor it as it was processing. So yeah, and of course, a lot of the other AWS services are automatically scale themselves like AWS, or sorry, like Lambdas and everything. So yeah, so that was our solution, and I think Dan, it'll be time for questions now.
Yeah, no, thanks so much for that, Duane. I really appreciate sharing your learnings there. Just curious, how well does your solution then integrate with the rest of your enterprise content management system and the data that's there? Like, are you able to then further apply some of the benefits of going serverless, like on the cloud, applying additional machine learning on some of the other documentation?
Yeah, we actually, so we didn't do anything where we took the results of this and put it back into the content server, but we actually were able to use this as a framework, and we did a POC for another business area totally, and it was very successful as well. And that's kind of in the early days, but so we took like another department's data, and they actually didn't want to do like a search per se exactly the same way. So it was easy to, the rest of the process, like grabbing the data out of the content server and then categorizing it with recognition and then extracting the text, was the same. And then we had to create some other custom code to, they had some specific content they wanted calculated once they got that text extracted, right? And then we put that into the open search for them to use. So yeah, I'd say for the most part, we were able to reuse quite a bit of our solution, like at least like 60% of it for another area. And yeah, there's lots of interest as well to, like, it's kind of early days, but there's been lots of interest in people trying to think, oh, how else can we do, or what other area can we do this?